So the last two videos that I did, we did one special case is where you cancel a binomial in the numerator and the denominator so that the function is a constant function, and then the graph is a horizontal line with a hole in it, or two holes in it. The last video, it was you cancel the denominator, and it winds up being a linear function, a slanted line, right, that has one hole in it or two holes in it. What we have here now is a general case. This is a cubic function in the numerator and a linear term in the denominator. Basically, what you want to find out is, does this function have a vertical asymptote at 2? Because 2, x equals 2, will make the denominator equal 0, because 2 minus 2 equals 0. So there is either a vertical asymptote at 2 or there is a hole at 2. Now, here's the key. There is a hole at 2 if 2 makes both the denominator and the numerator equal 0. But if 2 doesn't make the denominator and the numerator equal 0, if it makes the denominator equal 0 but it doesn't make the numerator equal 0, then we have a vertical asymptote. So the first thing that we can do is, in fact, that's the focus of this video here, is trying to understand just simply whether we have, whether the 0 of the denominator makes it a hole or a vertical asymptote. The best way to do that is to use synthetic division. Okay, so we're going to do synthetic division on this whole thing. We're going to put a 2 in the half box, a positive 2, because remember, we want to use the 0 of the denominator in the half box, right? So the 0 is positive 2. Then we're going to put a 1, then a negative 6, then a negative 13, then a 42. Then we're going to put a 0 here. 1 plus 0 is 1, times 2 is 2. Negative 6 plus 2 is negative 4. Negative 4 times 2 is negative 8. Negative 8 plus negative 13 is negative 21. And negative 21 times 2 is negative 42. Plus 42 is 0. What this means is that the numerator factors, you ready? Factors into, well, if this is a third power, what does this become? Isn't this is 1x to the second power, right? Because remember, in synthetic division, our power goes down by 1. So this is x squared minus 4x minus 21. Let me explain to you what this means. This means that the numerator factors into x squared minus 4x minus 21 times x minus 2. It's a theorem called the factor theorem. The factor theorem says that if you divide by a binomial factor using either long division or synthetic division, if the remainder is equal to 0, then that binomial is a factor of that polynomial expression. So this function factors into x squared minus 4x minus 21 over x minus 2. So basically, if you were to plug a 2 into the numerator and into the denominator, you would get 0 over 0. Okay? So here's what it is that I'm asking you to do in this part, in the video we're in right now, and then we have one more video after this, is I'm asking you to identify whether a rational function will result in 0 over 0 or some non-zero number over 0. And there's two possibilities. If you get not 0 over 0, it's a vertical asymptote. If you get 0 over 0, it's a hole. And those are the only two possibilities here. Okay? Well, I mean, there is the other possibility of not getting a 0 in the denominator, but we're going to plug in whatever will make the denominator equal 0, which in this case is 2. Okay? So what I would want you to do here is this: step 1. Find the 0 or zeros of the denominator. Step 2. Plug that 0 into, or the root, into the numerator, okay? And then if you get not 0 over 0, you're going to tell me it's a vertical asymptote. If you get 0 over 0, you're going to tell me it's a whole, okay? And then if it's a whole, then we can cancel the denominator and that number, and then we can possibly graph. But we'll do that in the next video, okay? So find the 0 of the denominator, plug it into the numerator, and then you're either going to get not 0 over 0 or you're going to get 0 over 0. If you get not 0 over 0, you tell me there's a vertical asymptote. If you get 0 over 0, you tell me there's a whole, okay? All right, so so in this case, when we plug, and the way that you plug the 0, so in this case, the 0 is x equals 2. The way that you plug that number into the numerator is you use what's called the remainder theorem, which uses synthetic division. So here's what you're going to do. Find the 0 of the denominator, use that, and do synthetic division on the numerator. If the remainder is 0, it's a whole. If the remainder is not 0, it's a vertical asymptote. So here we had gotten, again, let's do it again. We're going to put a 2 in the half box, and we get a remainder of 0. Because the remainder is 0, that means that, that we have 0 over 0, and this function has a whole, not a vertical asymptote. Okay, it has a whole at -2. All right, here's another rational function, and we're going to find out whether this function has a vertical asymptote or a whole. And so we're going to do synthetic division. What are we going to put in the half box? We're going to put -3 in the half box. -3. 14 minus 12 is 2. And so the remainder is not 0. Therefore, instead of having 0 over 0, we have 2 over 0. If we plug -3 in here, we'll get 0. But if we plug -3 in here, we'll get +2. 2 over 0 means that there is a vertical asymptote at -3 and not a whole. Let's try another one. All right, here's another rational function. Why don't you pause it, do some synthetic division, see if you get a remainder of 0, and decide whether it's a vertical asymptote at 5 or if it's a whole at 5. All right, so I'm going to do synthetic division here. I'm going to put 5 in the half box. 10 minus 6 is 4, remainder of 4. Because the remainder is not 0, if I were to plug 5 into the numerator and then plug 5 into the denominator, I would have 4 over 0. And that means a vertical asymptote at 5 and not a whole at 5. Let's try another one. All right, here's another rational function. Why don't you pause the video and find out whether this one has a vertical asymptote or a whole. All right, so this function could potentially have a vertical asymptote or a whole at x equals -9. How do I know that? Because I take the denominator x plus 9, set it equal to 0, and solve. Subtract 9 from both sides, and I get x equals -9. That means -9 is the 0, or the root of x plus 9. Okay? What we want to know is if now, is -9 a root of the numerator? If it is a root of the numerator, it will make the numerator also equal 0. Then we will get 0 over 0. But if it is not a root of the numerator, then we will get a non-zero number over 0, and that will indicate a vertical asymptote. So we're going to do synthetic division with -9. So put -9 in the half box. Is -9 plus 9 is 0. And so we have a remainder of 0, which means that -9 is a root of the numerator. And if we plug -9 into the numerator and the denominator, we would get 0 over 0, meaning that there is a whole at x equals -9. It also means that the numerator will factor into 2x squared plus 3x plus 1 times x plus 9. And since the denominator also has an x plus 9, we could then cancel the x plus 9, and we would have this left over where as the function where x cannot equal negative 9. Okay? So this is a skill that you have to be good at. It will help you prepare for calculus, and it'll help you have a really good understanding of how to identify holes and how to use synthetic division with rational functions.